We've made terrific progress over the time that I've been a plasma physicist. And we've reached the point now where we're at the threshold of being able to demonstrate scientifically a controlled fusion reaction using a magnetic field to confine this very hot plasma medium. The temperatures that we generate in these magnetic confinement devices, which are called tokamaks, which is a Russian acronym, those temperatures are 50 or 100 million degrees centigrade, so incredibly hot. Hard to imagine how hot they are. And the amount of gas that we actually contain using these magnetic fields is very small. But they're so incredibly hot that the pressure of the plasma can be very substantial and can be greater than the pressure of air in this room. And so we confine these using magnetic fields, because if something is 50 or 100 million degrees centigrade, well, you're obviously not going to, put it into a milk bottle or something and hope that you can confine it. So you have to confine it with some immaterial force. And the force we use predominantly is the magnetic field. So we make these magnetic bottles in which we place our plasma, we heat it using electricity, using radio waves, various forms of heating, and we reach the temperatures at which these fusion reactions begin to take place. And we're currently studying how the plasma is behaving inside of this magnetic confinement in such a way that it leaks out a little bit, which is, of course, the thing we're trying to prevent. We're trying to keep all of the plasma in. And so we're studying ways to prevent that leakage taking place. We're studying the ways in which we heat the plasma. We're studying ways in which, when there is a small amount of leakage, we can cope with that. We can ensure that what interactions there are with the material structures around the edge of the plasma are tolerable. And basically, we're studying the various aspects of the problem which will go up to make the engineering and science challenges that we'll have to face if we're going to turn this into a realistic energy source. And right now, we've reached the point, as I say, where we stand at the threshold of a scientific demonstration. We've designed an experiment that's in the beginnings of being built in the south of France, called the ITER experiment. And this is an experiment which, if successful, will demonstrate the production of fusion energy at the level of maybe several hundred megawatts of power for maybe a few hundred seconds or 1,000 seconds. And so this will not be something where we're going to connect it to the grid and power, houses and power plants from it. What we're going to do is we're going to study it and make sure we understand all of the details, scientific and engineering details of this. But that will then provide us with a basis on which we can move forward to what is called a demo or demonstration power plant, which would be the next step beyond ITER.